Types of SSD form factors. You are looking to improve the speed of your system with a new SSD. But how do you choose? Your decision will be determined in part by the type of storage connection in your system and its form factor, the SSD's shape and size. The SSD you choose will also have either a SATA or NVMe using PCIe storage interface. Over the years, SATA has been the more prevalent of the two. However, whereas SATA was designed for HDDs and later adapted for use with SSDs, NVMe was designed specifically for SSD usage. NVMe SSDs support multiple form factors, making it a versatile technology for many storage platforms from servers to all-flash arrays. NVMe is quickly catching up in popularity, becoming the industry standard interface for everything from the latest gaming consoles, laptops and desktops for end users to servers in the most advanced data centers. SSD form factors. 2.5 When shopping for SSDs, the first thing you'll want to know is which form factor fits in your system. SSDs come in many shapes and sizes. For example, 2.5 is the most common type of SSD and fits into most laptop or desktop computers. It has a similar shape to a traditional hard disk drive, HDD, and connects over SATA cables, so it offers a very familiar experience to what many are already used to. M.2 Another form factor, M.2, has become the standard type of storage for slim laptops and notebooks. Its tiny form factor is often compared to a stick of gum and is easy to install right on the motherboard in most cases. It is available in various lengths to enable different SSD drive capacities. The longer the drive, the more NAND flash chips can be mounted on it, leading to higher capacity drives. MS-ATA or Mini SATA is essentially a smaller version of the full-size SATA SSD. It uses a compact form factor like M.2 but is not interchangeable. M.2 drives can support both SATA and PCIe interface options, whereas MS-ATA only supports SATA. This form factor is designed for smaller form factor systems where space is limited. U.2 Finally, there's U.2, which looks like a 2.5 drive but is a bit thicker. It uses a different connector and sends data through the PCIe interface. U.2 SSD technology is typically reserved for high-end workstations, servers and enterprise applications that need greater storage. It allows higher operating temperatures and is more favorable for transferring heat than the M.2 form factor. Interfaces, SATA versus NVMe. The communications interface is the way your computer communicates with your PC. It's available in two types, SATA and PCIe NVMe. The SATA interface is more affordable, commonly found, and offers good performance for common applications. PCIe is the standard interface for NVMe, which is 3 to 10 times faster than SATA SSD. Most high-end M.2 SSDs launched in the last few years support NVMe, but not all M.2 are NVMe, some are SATA. NVMe is much faster because it provides more bandwidth than SATA models, which improves performance in heavier productivity applications. If your daily tasks consist of heavier work such as video editing and large file transfers, then NVMe SSDs would be a good choice. Now that you understand the differences between SSD form factors and their interfaces, your choice should be clear. Bear in mind the device you are upgrading when buying your next SSD. Whether it's a laptop, desktop or server, any SSD upgrade will provide a noticeable improvement from a traditional spinning disk drive. They are faster, smaller, more heat efficient, and able to withstand movement and accidental drops. Be sure to read your motherboard system manufacturer's user manual to confirm which form factor will work best with your device.